Hi everyone, this is Mrs. J, and today we're going to talk about transformations of functions. So before we start our lesson, I have a quick warm-up for you guys. So go ahead and pause the video and give this a try, and we'll check your answers in just a few moments. Alright, so go ahead and check. Here you can see I evaluated f of -2 and f of 3. This is a good review of order of operations. So remember, we always do our exponents first, and then we multiply, and then we add or subtract. So you should get these two results. You should get -2, 9 and 3, 19. And then you can use those 2 points to help you find the average rate of change. So essentially, you're just finding the slope of the line that would connect these 2 points, and you should end up with an average rate of change of 2. Okay, so here are the different types of transformations we're going to learn about today. So transformation is just a change to your graph or your function. So these basic transformations apply to any type of function that we're going to work with. So you'll notice that split up into vertical on the first row and horizontal transformations on the bottom. So let's start with what are called translations. So a translation is essentially just a shift up, down, left, or right. So a vertical translation is simply a shift up or down. So it might make your graph look something like this if you translate it up. Or if you translate your graph down, it might end up looking something like this. So notice that the overall shape of our graph didn't change. It didn't rotate or flip around. It simply moved up or down. So that's a vertical translation. Now, a horizontal translation is simply a shift left or right. So imagine, your graph just moves a few units to the right, or maybe a few units to the left. Looks like this. So again, the shape didn't change. There was no rotation or reflection. It simply shifted left or right. So we call this type of transformation a translation. The next type of transformation is called a stretch or a shrink. So you can have, again, a vertical stretch or shrink or a horizontal stretch or shrink. So for a stretch or shrink, that is vertical, imagine that you take your hands and you're holding the graph on the top and the bottom, and then you start pulling your hands apart from each other. This would be a vertical stretch. You're stretching it up and down, and you might get something that looks like this. So notice that when you do this, our graph is not extending in width. It's simply getting kind of taller and narrower. So again, we put our hands on the top and bottom and moved our hands apart. So then imagine you put your hands on the top and bottom and then you start compressing them together. That would be what we call a vertical shrink, and it would look something like this. So these are examples of what a vertical stretch or shrink might do to your graph. Now, a horizontal stretch or shrink, imagine you have a slinky. Imagine this is a slinky, and you put your hands on both sides of the slinky. So imagine you start pulling your hands apart from each other. We would call that a horizontal stretch. So your slinky would start looking more like this rather than the original graph. So it starts stretching horizontally. Now imagine you go back to our starting point still on your slinky, and you start moving your hands together. Your slinky will start looking something like this. So this is what we would call a horizontal shrink. We're shrinking our graph horizontally, or we're compressing it. But notice, throughout the entire process, our graph didn't get any higher or lower. It just stretched or shrunk horizontally. Now, the last type of transformation is called a reflection. So there's 2 types of reflections. there's a reflection over the x-axis, which results in a vertical type reflection, and there's a reflection over the y-axis, which results in a horizontal type of reflection. So for a vertical reflection, essentially anything that was on the bottom moves to the top and vice versa. So if we're going to reflect this graph over the x-axis, it would look something like this. So you can see that the x-axis is our line of symmetry for the reflection. Now this reflection over the y-axis, again, everything that was on the right will move to the left, and everything that was on the left will move to the right. So it would look something like this. So you can see that we used our y-axis as our line of symmetry for the reflection. So now that we know what these transformations look like, how they affect our graphs, we're going to be working with the transformations in terms of the equations, and we're going to be changing equations to make specific transformations happen. So here we're going to be talking about the rules of transformation. So the nice thing about transformations is that all functions follow the same rules. So if you know the rules and you can apply it to one type of function, you can apply it to any type of function we're going to learn about this year. So the first thing you should ask yourself is, what do you want to do to your function? So if you want to translate your function, meaning shift it up, down, left, or right, we're going to be using addition or subtraction. We're going to add or subtract to part of our function. So that will always be the case here. If you want to stretch or shrink your function, we're going to multiply part of our function by a positive number. And last, if you want to reflect your function in some way, we're going to be multiplying part of our function by -1. But now we have to figure out, well, what part of our function do we change? And that will depend on which direction do you want to go. If you want to move horizontally, so if you want to translate horizontally, stretch or shrink horizontally, or reflect horizontally, then you need to group the change with X. Anything that is horizontal needs to be grouped with X, which makes sense because on an XY axis, X is everything left or right, it's horizontal. And if you want to move something vertically or change it vertically, so if you want to shift it up or down, if you want to stretch or shrink it vertically or reflect it vertically, make sure that you do not group it with the X. You're actually going to make the change to f of x, which is your y value. So to change horizontally, you change the x value. To change vertically, you change the y value. So it's going to look something like this when we actually do it. So here are all of the vertical transformations that we're going to be doing, and we can do them by changing the f of x, which is the same as the y value. So notice here, this first one, you have f of x, and then we added k. So anytime you add a number to your y value or to f of x, it's going to shift or translate your graph up. Anytime you subtract from f of x, it's going to shift your graph down. Anytime you multiply by a positive number to f of x, so here we're changing the operation, we're multiplying, remember that's going to be a vertical stretch or shrink. So here, if your a value is less than or is greater than 1, we would say that that's a vertical stretch. It makes your graph stretch. And if your a value is less than 1 but still positive, it's going to shrink your graph vertically. And last, we said if we want to reflect, we multiply by -1. So if we multiply our y value or f of x by -1, that is a reflection, and it's actually going to reflect over the x-axis. So it's kind of seems backwards that if you multiply the y value, it reflects over the x value, but that's what a vertical reflection looks like. So notice again, adding or subtracting is a translation, multiplying is a stretch or shrink, and a negative reflects. So now we can apply those same things to our horizontal transformation. So notice here, if you compare the notation, all of these changes were done outside of the parentheses. They were not grouped with x. All of these changes are specifically grouped with x, making them horizontal transformations. So in the first two, we're adding or subtracting. Now this part is a little bit tricky. It might seem backwards at first, but whenever we're adding or subtracting from x, it will move it left or right. It's still horizontal, but it's actually going to go in the opposite direction that you think. So even though we're adding a number to x, this is actually going to shift our graph to the left. So it moves in the opposite direction that you think. Now the same thing applies for subtraction. So when you subtract from x, it's going to move in the opposite direction, and it's actually going to shift our graph to the right. Now for our horizontal stretches or shrinks, we're actually not going to work with these too much this year because it's a little bit tricky. It still is going to make a stretch or shrink because it is multiplication. But just so you know, the factor by which the stretch or shrink happens is actually the reciprocal of b. So it's actually by a factor of 1 over b. So a little bit different, which makes this a little bit trickier. So again, it's good to know that you can do a horizontal stretch or shrink, but we're not going to be working too much with this transformation this year. And then last, if you multiply your x by a negative, remember multiplying by -1 reflects, and this one reflects over the y-axis. So if you multiply the x, it reflects over the y, which does create a horizontal reflection. It does reflect left to right or right to left. So these are the basic rules that all functions will follow when you are applying transformations. So if you can get used to these rules now, it will really pay off in the long run as we can use them the entire year. Okay, so now we're going to see if we can put these rules into effect. So we're going to be writing a new function, which we're going to call g of x, in terms of f of x, which is the original function, which we can call the parent function, according to the following transformations. And then we're going to actually graph it. So we're going to sketch what that change would look like. So the first one, here's the graph f of x. They would like us to translate our graph left to. So first thing to note is that this is horizontal, left or right, so it does need to be grouped with x. So we can say g of x, that's our new function, equals f of x. And remember, if we want to translate, we add or subtract, and here we have to be careful. It moves in the opposite direction. So if I want to go left to, we're actually going to add 2 to x. That's the one that moves in the opposite direction. So by adding 2 to x, we have just shifted our entire graph to the left 2. So to graph this, we can pick points that we see clearly on our original graph, and we can just shift them all to the left 2. So I'm going to move from here and work my way over. So we can say here, 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 and here. And there you have it. Okay, let's look at example B. So here they would like us to translate again, but we're going to go up 4. So we're going to go up 4. So we're going to say g of x, that's our new function, equals, so remember, if we're going up or down, we want to make sure that we're adding to the y value or to f of x. We do not want to group it with x because this is a vertical transformation. So we say f of x, and then on the outside, then we say plus 4. And this one we don't have to do opposite. It's going to move in the direction we think. So again, take all of your points and just shift each one up 4. And that should give you your new graph. Oops, 1, 2, 3, 4, and it should look something like this. Okay, let's move on to example C. So here, f of x is stretched vertically by a factor of 2. So remember, whenever we see stretch or shrink, we're going to be multiplying. And since it's vertical, we want to multiply f of x. We want to make sure it is not grouped with x. So we're going to multiply by 2. So we say g of x equals 2 times f of x. So we've multiplied our y value by 2, stretching it vertically. So the graph for this, essentially you can take the points that we know again. So I'll put little dots on the ones we can use. And we're going to essentially multiply all of our y values by 2 because it's a vertical stretch. So here, instead of having y at 1, we multiply it by 2. We double it. Here, sorry, this was -1 to -2. Here, 1 we multiply by 2. 0 stays at 0. And this goes down to -2. And this goes up to +2. So our graph looks like it's been stretched out vertically. All right, let's look at example D. So here, f of x is reflected over the y-axis. So remember, if we want to reflect over the y-axis, we need to multiply the x by -1. So we can say g of x equals f of -x, which will cause a horizontal type reflection. So again, for that, imagine that this line here is our line of symmetry, and everything that was on the left will reflect to the right and vice versa. So this point will reflect 2 units to the other side. This point will reflect 1 unit, and then 1 unit and 2 units. So we get a graph that looks like this. So remember, to reflect over the y, we multiply the x by -1. Okay, for example E, f of x is translated right 1, down 3. So here we actually have 2 transformations. So let's see if we can do both. So we're going to do right 1 and down 3. So we know that anything with a translation, we're going to be adding or subtracting. So this entire process for example E is all addition and subtraction. So the first one is right 1. So since this is horizontal, we need to make sure we group this with our x. So we'd say f of x. And remember, to go to the right one, we're actually going to subtract 1 from x. Now, down 3 is vertical, so we're going to add or subtract from f of x. We're going to do it on the outside. And to go down 3, we just subtract 3. So this caused our graph to go right 1. This causes our graph to go down 3. So pick your points that you know, and we're going to move each point to the right 1 and then down 3. So right 1, down 3, right 1, down 3, right 1, down 3. And here's our translated graph. Okay, let's look at this last example. This should say example F. So f of x is vertically shrunk by a factor of 1/2. So it is a vertical transformation. So we're going to make sure it is not grouped with x. And since it's a stretch or shrink, we're going to be multiplying. So we're actually going to multiply f of x by 1/2. So g of x, our new function, is going to be 1/2 times f of x. Again, notice since it's a vertical transformation, we want to make sure the change is not grouped with x. Now for this, kind of similar to the vertical stretch, we'll just multiply all of our y values by 1/2. So our graph will only be going half as high, and it will look something like this. Okay, so here I have a couple you tries. Please pause the video and give them a try on your own. And when you're ready, you can hit play and we can check your answers. All right, so let's check your work. So here in example A, we have translation, so we know we're going to be adding or subtracting. To go left 1, we actually add 1 to x. To go down 5, we subtract 5 from the entire function. And then our graph would look something like this. Just pick points that you know. So I would use this point, and this point, and then translate them accordingly. Part B, f of x is reflected over the x-axis. So to reflect over the x-axis, you actually multiply the f of x by -1. So notice it's on the outside of your parentheses. It is not grouped with x. So this is what your reflection would look like. Notice the x-axis is that line of symmetry. And here, vertically shrunk by a factor of 1/4. So we're going to be multiplying because it's a stretch or shrink, and we multiply f of x because it's vertical, and then we multiply by 1/4. So you can see that this point, instead of being up here at 0,4, it's at 0,1. So it kind of just looks like we've kind of squished it down from the top. So this last thing we're going to talk about really quick is a different way we can classify functions. And so some functions we can classify as either even or odd. So by definition, even functions follow this rule: g of -x equals g of positive x. This pretty much means if we have a positive value, let's say this is +2, and then we have that same value but the opposite, so the positive and the negative x version, it's saying that it would give you the same y value. So you can see here that they both have the same y value. So the opposite x values have the same y value. So we call this an even function. Another way to describe even functions is that they always reflect over the y-axis. Now, odd functions, they follow this rule: h of -x equals h of x. So again, imagine we have the same two values for x, but one is positive and one is negative. So this says that when the x values are opposite, the y values are also opposite. So let's say this hits here at +1, that would mean this would be -1. So again, when the x values are opposite, the y values are also opposite, but still the same absolute value. So we call this an odd function, and we can also say that odd functions reflect over the origin. So remember, the origin is this point right here. So you can see that it reflects diagonally over the origin. Everything that was upper right is now lower left. Everything that was upper left is now lower right. Okay, so that is all for today's video. Thank you so much for watching.